Hello, in this video we will be solving the two-sum problem and also try to compute the space complexity and time complexity of the solution that we built, and we will be using JavaScript in this video to reach the solution. Before jumping into the solution aspect of it, let us first try to understand what is this two-sum problem. So let us say we have an input array nums which looks something like this, and we have a target of 9. The two sum problem states that find two elements in this specific array that will add up to 9. So we need to find x plus y that will be adding up to 9. From this simple example, what we can see is we have 2 here plus something will add up to 9. And 9 minus 2 is 7. If we have 2 and 7 in the array, basically these are the two elements that compute the target when we add them up. And the problem statement says that I want to get indices of these two elements in the array, and we assume that each array will have exactly one solution and we can return the indices in any order. What I mean to say is when I say 2 and 7, this is at index 0, this is at index 1, this was at index 2, and this was at index 3. 2 has index 0 and 7 has index of 1. So my output is going to be this, and this can be written in any order. It doesn't have to be 0, 1, it can also be 1, 0, as long as the indexes are correct. This is a rough overview of what the two-sum problem is, and let us now jump into the solution aspect of it. When we try to solve this in JavaScript, what we can do is try to use a data structure which is provided inbuilt in JavaScript, and try to reach a solution to get the indices from the array of the two elements that we are looking for. And we know that we will always have a solution in the scope of this problem. That's the assumption that we make. So what I want to do is I want to use a data structure. In this case, it's a map which I will be using, and with this map I will try to track which element exists at which index in the array, rather than every time trying to find what is the index of my element that I will be returning as part of the two elements that become the sum that I'm looking for. And at the start we assume that there's always going to be a solution. So in case we don't find a solution, we will have to return something for sure, because the problem is always going to have a solution. So when I say let us iterate, I will basically use a loop there, and then if you don't find your solution in the loop, I need a default return from this function. So when I say I iterate, I will just say loop through my array of nums, and let us have a logic inside this section of the function, and we will also have a default return which we will come back to later. And as we saw earlier, we will be having a mechanism something like this, wherein two elements compute the target. So I will say element 1 plus element 2 equal to target, and when I iterate through the array, I will know what my first value is, and then I just need to find my second value to reach the solution. What I mean by that is, if I know 2 and I know that I need a target of 9, I just need to find 7 in the array, and that is my solution, which basically converts into simpler words to something like this value which is my remainder element value, is target minus my element 1. So what I will say is constant remainder is target minus my current element, which is nums of I, as I am iterating through the array. I said that I will be just putting all the elements that I see inside my map against the indexes. Inside a map, we have key and value. As part of the key, I will be putting the element or the value from the array, and as part of value, I will be putting the index of that specific value. So I will say tracker map dot set nums of I, comma I, having the index. So this basically is going to be my index, and this is going to be my value. And now you will say, what do we do now? You are just putting everything inside the map. As soon as you find it, what are we returning? Next is the part where we try to return something. Now when we say we try to return something, what do we want to return? We want to return the index of the first element and the second element, which add up to the target itself. Now I know that my first element is 2 in case of this example. So let us say that we try to go through the iteration, and we say iteration 1. We come here, we see that remainder is target minus nums of I, which is 2 in this case. So we will say iteration 1 is target minus 2, which is 7, and then the tracker is just going to set nums of I, which is 2, and the value of its index in the map. So this is going to be the state of the map in the first iteration. Now comes the second iteration, which says again remainder is target minus nums of I. So 9 minus 2, 7, which becomes 2. And here we know that 7 plus 2 is 9. So in actuality, I know what my solution is from this example, but how does it convert into the logic aspect of it? I put during my first iteration inside my map the index against 2. Now what I need to do is, when I come in the second iteration, I know that remainder is 9 minus 7, which is 2. So I just need to know if 2 is there inside the array, and then I will just return the index of this element. So I can just check if tracker map dot has remainder, which is 2 in this case, then I will just return I, which was 1 in this case, because that's the index of 7, and tracker map dot get remainder. Why get remainder? Because in the first iteration that we saw here, we put against 2 what was its index, and in the second iteration we know that 2 is the remainder, and if we get it, we just return the solution. That's pretty much it. Now if for some reason something goes wrong and we don't have anything inside this loop being written, we need a exit condition. We can have a exit condition something like this, because at the start we said it's always going to have a solution. So if something goes wrong, if there is a edge case, you just return 0, 1 as part of edge case handling mechanism in your solution. It's always good to have a edge case mechanism to ensure that your function doesn't say stuck, or For instance, in this case, if something weird happens, then you won't return anything. So we want to basically return something from this function, and this is that default return after your logic is executed. And that's pretty much it as part of the solution. Now, when it comes to computing the time complexity of this, we said that if you have nums of I will just iterate through nums of I and keep putting data into the map. This basically is going to be time complexity of order of 1 when you just want to insert into the map, or if you just want to check something from the map. But we are going to be doing this until we have elements in the array. So if you have, let's say, n elements in the array, we will be iterating n times. Hence, time complexity is also order of n, because even though this is order of 1, this is order of 1, this is also order of 1, we keep doing this n times as long as you have elements in the array. So that's why the time complexity is order of n. And when it comes to space complexity, that is also order of n, because this tracker map is going to have n elements, in the sense that if you have 20 elements in the array, we are going to store 20 elements in the map as well, which can be unique. So if you have maybe some duplicates also, in worst case scenario, you will possibly reach the counter of n, or at least n minus x if you have a few duplicates. So it's going to be a variable based on the size of your array. Hence, the space complexity is also order of n. And that's pretty much it. Thank you for watching. Please like and subscribe. Thank you.